Okay, so let's solve this example 14.7, which is the first problem that involves phase change. Remember, when we have phase change, during the process of changing the phase, the temperature does not change. And the Q, the equation that we use for Q is ml. If we are extracting energy, if we are going from vapor, now from gas to liquid, or if we are going from liquid to solid, we'll have to put a minus sign here. If we are injecting energy, so if we are going from ice to liquid, if we are going from liquid to steam, we'll have a plus sign here. Very well. So let's read this problem. The question is, how much energy does a freezer have to remove from 1.5 kilograms? Okay, so this is the problem. How much energy does a freezer have to remove from 1.5 kilogram of water, liquid water at 20 Celsius, to make ice at minus 12 Celsius? That's the question. Okay, so let's rewrite this problem here. We have this mass, 1.5 kilogram of water, liquid water, originally at this initial temperature of 20 Celsius. We want to end up at this final temperature of minus 12 Celsius. So at this point we have liquid water. At the end we will have ice, solid. So what are the steps involved in this problem? There are three different steps. First, we will go from 20 Celsius to 0 Celsius. Okay? So we will bring the water to 0 Celsius. So this is the first step. So I'll call this my first step. Second step. Second step, we will keep extracting energy, but now the temperature is not going to change. We will be fixed at 0 Celsius. What is going to be happening here is a phase change from liquid to solid, right? From water, liquid, to ice. Then there is a third step. Once all this water became ice, we are going to keep extracting energy to lower the temperature of this ice from 0 to its final temperature of minus 12 Celsius. So we have these three different steps. In all of them, we are extracting energy. Okay, so let's write this. What is the total amount of energy that is being extracted? What is this total Q being extracted? Well, is the Q to go from 20 to 0. Then the Q for the changing phase from liquid to solid. And then finally the Q to go from 0 all the way to minus 12. Okay, so let's write this down. The mass is 1.5 everywhere, is the mass that we started with. So there are two different equations that we can play with. The two different equations are Q is equal to mc delta T and Q equals to ml. So let's see which one is the appropriate one for each case. So as we go from 20 degrees to 0, we are changing temperature. There is no phase change. So here we have this equation, the mc delta T. So it's going to be 1.5. The C, we have the C for water. Let's double check what it was in our table. C for water here is 4186 in the international system. So let me put here 4186. And what is the change in temperature? Well, the final is going to be 0. The initial is 20. Okay, so I'm going to put here 0 minus 20. Well, I could just have written minus 20. Okay, then comes the phase change. This is the phase change. The phase change, what is the equation that we use? This one, ml. M is still 1.5. This mass has not changed. What is L? Well, let's go to the table of the latent heat. The latent heat, we are here in water. We are going from water to solid, now to ice. So we are going to use this 333 multiplied by 10 to 3. Remember that this unit is kilojoule and we want to write everything in joule. So I'm going to put here this 333 multiplied by 10 to 3. But wait a second. We are changing from liquid to solid. We are extracting energy. So let's make a correction here. We remember what we said. Extracting means minus. All right. Let's go for the next step. The next step is this final step where everything now is ice. We change the phase and now we want to keep lowering the temperature. We still have the same mass. So the same mass, 1.5. C, we have to put the specific heat. Very careful now. We don't have liquid water anymore. We have ice. What is the specific heat for ice? Well, let's go back to our table. Our table for the specific heats. Here we are in the region for water. This is liquid. That's the one that we had used before, but we don't have liquid anymore. Now we have ice. And so we have to put this 2100 joule per kilogram and Celsius. Okay, so 2100. Be very careful, and I'm going to put this in red so you pay attention. The specific heat now is 2100 because now we have ice. We don't have liquid water anymore. Okay, well, let's go back to our problem. We are here, right? And then, well, what is remains to put here? The change in temperature. So the final temperature is going to be minus 12. The initial is 0. So this number here is minus 12. Okay? So this is what we have to do. Be very careful. There are many important steps here. There is the story of the specific heat. Once we change phase, the specific heat also changes. There is the story of extraction. So we are going to write that ml, but with a minus sign when we are extracting energy. If you put all these numbers there, you're going to get that this total Q extracted is minus 660 kilojoules. Okay, so this is how much the freezer extracted from this water to transform into ice and lower its temperature all the way to minus 12. How do we write the answer of this problem? Well, we don't need to carry this minus sign. Okay, the final answer of the problem is how much did it extract? How much energy did the freezer extracted? Well, it extracted 660 kilojoules. You don't need to put the minus sign there. This minus is in the word extracted, is in the word removed. Okay, so you could write, what is the answer? Well, the freezer removed 660 kilojoules. Okay, well, if you want to write with the minus sign as we did here, that's correct, but it's suffice, it's enough to say extracted 660 kilojoule. Extracted means negative. Okay, so that's the end of this problem.